Okay, welcome to the last part, which is the part 4 of part 1, which is the part 4 of chapter 1. Okay, chapter 1 is a very lengthy, IT generally is a very lengthy material. Imagine the number of pages having just 6 chapters, so definitely is something that we cannot learn in one video. It's gonna be very lengthy and it's going to take a lot of time, so that's why I splitted it into these 4 parts, and I believe that you've gained one or two things. So I said it in my last video. I said if you'd want to continue beyond just watching the video, click the link in the link in the bio so that you can join the group that are preparing for this coming examination. And I believe that by doing so you have people to rub minds together with, and also you have access to past questions and just reaching out one-on-one, throwing your questions, getting answers, and just clearing your doubts about some subtopics and things that is not very familiar with you. Okay, so now this is the last part, just like I said, and we are starting with section 1.9. You can check it in your material. Section 1.9 is data acquisition. Data acquisition. This comes from the word acquire. Okay, data acquisition. So data acquisition is the general process to be precise, by which phenomena from the real world is captured and recorded in digital format. Okay, so data acquisition is the general process by which real world information, real world data is captured and recorded in digital form. It's taken into the computer. Okay, it's captured and recorded in digital form. So data acquisition system. So there is now DAQ. Okay, you might probably see something like DAQ. DAQ. Where is my pen? Okay, DAQ. Something like DAQ. So DAQ is data acquisition. That's what it means. Okay, so we have the system, we have the software. So data acquisition system make use of sensors and transducers, that's analog devices, to collect data. I'm going to explain in real life example, okay, because I know it's still confusing. So the data acquisition hardware converts analog signals to digital signals and vice versa. So the converted data is processed and recorded by a computer running data acquisition software. So data acquisition system and data acquisition software. So let us explain. Data acquisition, acquire, from the word acquisition, from the word acquire, is how data from real world is being getting into the computer. And when we say data from real world, we're talking about even to the smallest of Siri, play me Duduke by Simi. I just hope Simi is the one that sang Duduke. I think she is. So something like that. Alexa, on the light, switch on the light, switch on the TV. Your voice is a physical, that is a real world data. Okay, but now getting it into the computer is the process, that system of your real world data getting into the computer to be stored and to be processed is data acquisition system. Okay, the whole system is data acquisition system, but the software that makes it to happen is data acquisition software. Okay, I'll give you many examples, so don't worry. Okay, we'll get there. So when you tell Alexa to switch on the TV, your voice is regarded as analog, because I know you've seen something like the data acquisition hardware converts analog signals to digital signals. So it's an analog signal. But we know that computer works in zeros and one binaries, okay? So therefore there needs to be a form of conversion, okay? So analog needs to be converted to digital, okay? Digital signals is zeros and ones, okay? So, or signals that has just two states, on off, like your switch is on off. So that one is digital signal already, okay? It's just being processed. But if you use your voice to say on the light, even though the light is on and off, that's two states, for the fact that you are using your voice, it is an analog what? Analog signal. I hope you understand it. So data acquisition system makes use of sensors and transducers. So have you ever thought of how those weather forecasts makes, to some extent, accurate prediction of what is going to happen? They'll tell you there is 83% chance of rain falling, there is gonna be too much of this, too much of that. How are they doing it? Have you ever asked yourself that kind of question? So there is a software, there is a system called data acquisition system and data acquisition software that makes that kind of thing to happen. So the sensor, they test the humidity of the weather, and use that there's a sensor, that's data acquisition hardware, that they use to collect, and there is that converts the analog signals using the data acquisition software to digital signals that the computer, okay, can record and work on. I hope you understand this thing. I hope you just understand it, okay? So it happens in so many ways. It happens in even electronic vehicles. It happens in it. You have so many things, that your speaker, even your mic, those that speaks to the mic, that's when you speak to the mic, that's analog being converted to digital. When you want to listen to music, you want to dance to the hip hop, to Cheche Kule and the likes. So your speaker singing it out is digital being converted to analog, because that's what you can hear sound. You don't read sound. You don't read sound like zeros and ones and everything. You don't read it, you only hear sound. So it has to be converted. That process is what data acquisition is all about. So element of a data acquisition system. Let us quickly look at the element of the data acquisition system. So we have the sensors, that's analog devices that collect the data. We have the data acquisition hardware, and that is the hardware that converts AD, that's analog to digital, and digital to analog converter. Okay, so we have the computer, that is the system, the computer with data acquisition software. Okay, then we have the display, storage, and control, what is being done to the data. Okay, the display, storage, and control. So those are the elements of a data acquisition system. Now, types of signal, and I think I've explained this. We have analog signal, a signal that changes continuously. Okay, sound, temperature, light, human voice, all of these are analog signals. Now, digital signals, a signal that has discrete value, discrete, 0 and 1. Computers work with digital signals. So conversion, analog to digital, that's AD. convert continuous analog signals to digital form, and digital to analog, that's convert digital signal to analog form. Example, when we speak into a microphone, the sound is analog, is converted to digital data by the computer. When we listen to music from the computer, digital data is converted back to analog sound through speakers. The major function of data acquisition system is, listen, the major function, here's my pen, the major function of data acquisition system is data conversion from analog signal to digital format and vice versa. That's the main point of data acquisition, okay? And that is what data acquisition is all about. Now we move to section 1.10, which is data cleansing. What is data cleansing? Data collected from various sources may be dirty, and this will affect the accuracy of predicted results. Okay, so data cleansing offers better data quality, which helps organizations to make sure their data is ready for analysis. So what exactly is data cleansing? So data cleansing is the process, it's a process, okay, of identifying, detecting and correcting errors in data. It's as simple as that. Identifying, detecting and correcting errors in data. Correcting must be there, but you cannot correct if you don't identify and detect. Okay, so that's why identifying, detecting and correcting errors in data is what data cleansing is all about. So process of data cleansing, now we want to look at the process. So we have specifying the quality rules. Okay, specifying the quality rules. I'll give you an example. Okay, I'll give you a real life example. Let's say in your class now, they said, okay, we are only, the data that you want to collect is, the quality rule is that you must only collect or pick out boys with let's say a measured height. Okay, so that means it is not all boys in the school that fit into that category. Okay, so even if all the boys are being reached out to, their data are being collected, there is a quality rule that must be specified. That's the first thing. We are only selecting boys with so height. So that is a quality rule that must be specified. Now number 2 is detecting data errors. So others that doesn't fit into that height range being sorted out. Yes, you've taken their data, but they now need to be sorted out. So that's detecting data errors and repairing or correcting the errors. So this one are the ones that we want to work on, this one are the ones that we have to let go. Okay, so that is the process of data cleansing. Specifying the quality rule. This is what we need. We have collected the data. This is the ones that are to let go. This is one that we are to work with. So that is the process of data cleansing. Challenges is more than that. Like that is, it goes beyond what I just explained. But that's just the first set. I believe that's the beginning aspect. Okay, that's just a first level understanding of what the process is all about. So challenges: incompatible data format. Those are the challenges of data cleansing. Incompatible data format, incomplete data, non-aligned data structure, inconsistent data. This can affect the analysis results. Data cleansing is very common in big data. Okay, so you will need to know that when in big data, data cleansing is very common. It's very common. You cannot be a data analyst without knowing how to without knowing data cleansing. Okay, you cannot be a data analyst without knowing data cleansing. Even financial analyst, you definitely know data cleansing and all of the likes. So benefits of data cleansing: number 1, removal of errors when multiple sources of data are involved. These are the benefits of data cleansing. Removal of errors when multiple sources of data are involved. Fewer errors makes for happier clients and less frustrated employees. Ability to map the different functions and what your data is intended to do. That's one of the benefits of data cleansing. Monitoring errors and better reporting to see where errors are coming from, and also fixing incorrect data for future applications. More efficient business practices and quicker decision making is enhanced through data cleansing. So that is what data cleansing is all about. Now let's move on to the next one, which is data analysis. So data analysis is the process of examining data carefully to obtain useful information and conclusion. There's no better way to explain data analysis but analysis from the word analyze. So data analysis is the process of examining data carefully to obtain useful information and conclusion, okay, for better decision making. In the past, quantitative and qualitative data were analyzed manually, okay, and when we say manually, we are talking about using paper and calculator. But the downside to that is that the processes were very slow, stressful, and less accurate, because it's pen and paper with calculator. Human error are common in the past. So nowadays, due to the advent of sophisticated and powerful software, data analysis has become more convenient, easier, faster, and more accurate. Okay, so types of data analysis: we have quantitative analysis and we have qualitative analysis. When we say quantitative analysis, we are referring to analysis that involves numerical data. Okay, analysis involving numerical data. Example: sales figures, student score, population data, profit calculation. All of these are examples of quantitative analysis because they involve what? Numerical data. Okay, qualitative analysis involves non-numerical data. Opinions, interviews, observations, customer satisfaction. All of these are examples of qualitative analysis. Software used for data analysis, because we said nowadays we use software. Okay, so what are the softwares? Examples of softwares used to analyze data. So we have SPSS, SAS, and we have NUDIST. So SPSS stands for Statistical Package for Social Sciences. That's SPSS. SCS stands for Statistical Analysis System. NUDIST stands for No Universal Definition in Statistical Terms. Now, what are they used for? SPSS is widely used for educational research, surveys, and statistical analysis. Can analyze large data, generate reports, tables, and charts. That's why this SPSS is mostly used for school projects. When you are doing your projects, you definitely use process. When you get to chapter 4, if it is, definitely use SPSS for your research, for your surveys, for your statistical analysis. You definitely use SPSS for the report. Okay, now SAS is mainly used for quantitative analysis. While NUDIST mainly used for qualitative. That's why we call no universal definition in statistical terms. Is mainly used for qualitative. Here's my pen. Okay, qualitative analysis. A school may use SPSS to analyze students' performance, attendance, examination results. This helps to discover weak subjects, best performing students, and trends in results. Now, benefit of data analysis: we have 4 mentioned in the material. We have better decision making. Organization understands situations clearly. Faster processing. Software saves time. Improved accuracy. Computer reduces calculation error, that's human error. Better prediction. Organizations can forecast future trends. So summary, data analysis means examining data for useful information. That's number one. Data analysis may be quantitative based or qualitative based. Quantitative, that's numbers. Qualitative, that's descriptions. Modern software makes data analysis faster, easier, and more accurate. Common data analysis software: SPSS, SAS, and NUIDST. No universal definition in statistical terms. No universal definition in statistical terms. So let's move on to the next one, and this is computer system. We want to look at section 1.12, and that is computer system. So a computer system is an electronic machine. This one, I don't think you have a problem with it. Okay. So a computer system is an electronic machine that accepts data, processes it, stores it, and produces information. In short, just to add to this, I believe when we first heard IT, that you'll be writing IT in your ATS examination, one of your ATS examinations, you feel like, I believe many people assume is this part alone, that is talking about evolution of computer, types of computer, the specifications, and all of the like. So but it's more than it's more than that. So but we are here. Computer system. A computer system is an electronic machine. Electronic machine uses electricity. Okay, that's where it comes from. Electronic machine that accepts data, processes, store it, and produces information. Now, evolution of computers, hardware only. Computers did not become modern overnight. Okay, just like the way you are not this age overnight. You grew daily, weekly, monthly, yearly to what you are, to the age you are now. So computers did not become modern overnight as well. They developed gradually through different generations. Each generation became faster, smaller, cheaper, and more powerful. Okay, so the 5 generations of computers. We have the first generation, second generation, third generation, fourth generation, fifth generation. We all know that. The period is 1939 to, for first generation, the period is 1939 till 1954. That's the first generation. Second generation, 1954 to 1959, just 4 years. First generation is like this should be 15 years. 15 years. Second generation is just 4 years. Third generation is 12 years. Fourth generation is, we still have it, and fifth generation is present to beyond. And the main technology used, we have vacuum tube transistors, integrated circuits, microprocessor, artificial intelligence, and nanotechnology. Now, what is the best way to remember this? If you can remember VTMA, you have it already. V stands for vacuum tube, T stands for transistors, I stands for integrated circuits, M stands for microprocessor, A stands for artificial intelligence and nanotechnology. VTMA. So let's check the first generation. The main technology is vacuum tubes. The feature is it uses vacuum tube technology, supported machine language only. What is machine language? Machine language is the binary language. Okay, we are still coming to that when we get to software. The topic software, we'll learn a lot about machine language and softwares generally. So machine language is 0 and 1. Okay, that's machine language. It's very expensive, produces much heat, requires air conditioners. Having a laptop, how you have a conditioner, Slow input and output devices, very large in size, not reliable. Exam point: first generation computer uses vacuum tubes. Second generation computers, that's the 4 years. Main technology is transistors. The features: it uses transistors, more reliable, smaller in size than first generation, produce lesser heat than first generation, consume less electricity than first generation, faster than first generation computer. Transistors improved computer performance greatly. Third generation, that's the 12 years. Integrated circuit, used integrated circuit, smaller and cheaper, faster processing speed, used high level programming language. When we get to software, you understand this as well. Use high level language, and when we say high level language, we are referring to human, understandable language to some extent. Human understandable language. We have the machine language, we have the low level, and we have the high level. So, but high level is very close to human language when writing programs. It uses magnetic storage. It uses magnetic storage. So third generation computer introduced integrated circuits. Now let's move on to the fourth generation computer, 1971 to present. Microprocessor. This generation introduced personal computers, PC. The processor was placed on a single chip. Use VLSI technology. What is VLSI? Very large scale integrated circuits. That's what it means. That's what VLSI stands for. Very large scale integrated circuits. It is portable, PC, and reliable. Cheaper than earlier computers. Introduced personal computers, faster processing, used floppy disks, introduced office software, that's your Microsoft Word, your spreadsheets, that's Excel. You have your Access and so many other presentation, PowerPoint. So internet development began during this stage. Most modern desktop and laptop computers belong to fourth generation. Now, fifth generation computers, we are referring to artificial intelligence. Fifth generation computers try to imitate human intelligence. Okay, imitate human intelligence. Uses ULSI, that's ultra large scale integrated circuits. Technology: artificial intelligence development, ChatGPT, Gemini, cloud AI. You have many of them. Natural language processing, that's there's direct data acquisition, that's analog to digital, digital to analog. Take me to so bus stop in your EV car. There's direct natural language processing. There's parallel processing, superconductor technology, multimedia and user-friendly interface, UI UX. Very nice UI UX. So AI chatbots, smart robots, voice assistants, self-driving systems are examples of the fifth generation computer. So the final summary: first generation 1939 to 1954. Second generation 1954 to 1959. Third generation 1959 to 1971. Fourth generation 1971 to this present time. Then fifth generation, this present time to beyond. So vacuum tube, transistors, integrated circuits, microprocessors, artificial intelligence. So let's move on to types of computer. Okay, and I know you understand this one, so I won't take much on it. On the basis of how data is represented, data representation, if you remember, we did that in part 4, data representation. So we have digital computers, works with digits, zeros and one. Analog computers work with continuous values. Then we have hybrid computers, combination of digital and analog. On the basis of purpose, so on the basis of how data is represented, we have digital, analog and hybrid. On the basis of purpose, we have general purpose and special purpose. For general purpose, it performs, those kind of computers perform many different tasks. Okay, they perform many different tasks. While for special purpose, they perform specific tasks only. And we are still going to get to the examples. Okay, on the basis of size and processor, that's on now general purpose. Based on size and processor, we are talking about supercomputers, mainframe computers, mini computers, microcomputers. So supercomputers are very large and very powerful. I think supercomputers are special purpose computer. They are mainly for specific tasks. Mainframe computer, large computer used by big organizations. Mini computers, medium-sized computers, and the small computers for personal use. So now these microcomputers we have different types of microcomputer. So we have the desktop computer, mini computer, mini tower computer, workstation, notebook, laptop, palm top, pen computer. So desktop fixed computer used on the desk, vertical system occupies less space, high performance. All of these are what I believe we know. Okay, now let's move on to the advantage of computer. Advantage of computer, we have the speed, we have accuracy, we have storage, can store large amount of data, we have reliability, we have automation, versatility. Versatile means can perform many different tasks at the same time. Communication, helps people to communicate easily. Efficiency, improve productivity in all fields. Okay, so computers work very fast and save time. That's for the speed. Produces correct results when correct data is entered. That's accuracy. And that's the reason why we have produce correct result when correct data is entered, is because it is what you put in is what you get. Giggle, garbage in, garbage out. You understand? So advantages show how computers help in daily life. That's the advantage. Now we are moving to the last slide, which is the disadvantage of computer and some other information. What are the disadvantages of computers? There's nothing that have advantage that doesn't come with its problem. There's no solution without its problem. So the disadvantage of computer is that it results to unemployment of some specific tasks, because some tasks are being carried out by the computer. So therefore, workers that are assigned to such tasks are no more needed. So unemployment, high cost. Computers and their maintenance are expensive. High cost, cybercrime, what we have today, health problems, security risks, dependence on electricity, electronic device, environmental problems, addiction and distraction. There are so many people that I want you to do something for me. I want you to check your phone and check the number of hours you spend on some social media apps per day, and you feel like, wow, just to do your audit, just audit the kind of time you spend on this app and ask yourself, what do I actually get from the number of time I spend on this app? Okay, what is the value of this kind of time I spend on this app? Because addiction will not tell you I'm addicted. It's just an habit that builds up, and you find it that's more to do without. Okay, so check yourself. Very important. Computers are very useful but must be used wisely and responsibly. Now we want to look at the comparison table. Analog versus digital computers. So data representation, analog computer uses continuous values. And when we say continuous values, we are referring to like now you want to increase the volume of your radio set. That is a continuous value, because it's not just loud, not loud. Even the loud has degrees, so that's continuous value. But digital computer uses digits, 0 and 1. Okay, on off, on off, on off. So accuracy, analog is less accurate, digital is more accurate. Speed, analog is very fast, digital is fast. Programming, analog is difficult to program, while digital is easy to program. Examples of analog: speedometer, thermometer. Examples of digital: you have computer, you have your laptop, you have calculator. Now, uses, who use analog computer? Scientific measurements. Okay, is analog is used for scientific measurements, while digital is used for general purpose work. So we want to look at general purpose and special purpose computer. So features now. Function. General purpose performs many tasks. General purpose is flexible and versatile. Okay, flexible and versatile. Programs can install many programs. That's for programs. General purpose can install many programs on your computer. You have or even on your phone, you have WhatsApp, you have your alarm, you have your date, you have your calendar, so many apps, okay, that are installed. So that is one of the feature of general purpose computer. It can install many programs used in home, schools, and offices. Okay, example: desktop, laptop. These are examples of general purpose computer. For special purpose computer, performs one specific task. Okay, when you use it, you know you are using it for one specific task. It has limited function. Okay, it is for programs fixed. The programs used is fixed and pre-written programs. It is used in machines, devices, and control systems. Example is ATM. You cannot say you want to go to ATM to watch YouTube. It's impossible. No, you go there because you want to withdraw money, or you want to, do some financial transaction. That is, is able to do, that is designed to do. So you have traffic light. So traffic light is also an example of special purpose computer. You have your street light. Street light is also special purpose computer, the ones that have sensor. When they sense darkness, they switch on. When they sense light, they switch off by themselves. So that is an example of special purpose computer. And washing machine controller is a good example. Now, supercomputer versus microcomputer. Supercomputer is very large. That's for the size. For processing power, extremely high. It processes a lot of things. Cost, very, very expensive. Supercomputer is very, very expensive. Users, used by large organizations and scientists. Examples: Summit, Frontier are good examples of supercomputer. You can even, I want you to check more examples of supercomputers and let me know in the comment sections what they have. So microcomputer, very small. Microcomputer in size is very small. Processing power, low to moderate. Relatively cheap. Okay, it is relatively cheap. And used by individual users. Okay, is used by individual users. Examples: we have laptop, desktop. So exam point: learn the types, features, advantages, and disadvantages of computers with examples. Very important. And this brings us to the end of chapter 1. Whew, it's a lot, but it is important. Okay, it is important. And if you think this is nice, as usual, subscribe, like, share, and comment any difficult section or subsection in chapter 1 that you feel is not clear to you enough, or you think I did not cover. And if you have any question at all, or you have anything to say, comment section is there for you to say it. So please share to your friends and colleagues that are preparing for this examination. Share. It's not a bad thing to share to people. It's something that is going to help them, so share. And I'll see you in chapter 2. Bye.